All right, so this is just going to be like a little talking video. Someone asked me in my Discord, like, what are some good places to find advanced topics of web dev? And it kind of got me thinking, like, what are the advanced topics? Like, what are some things that, maybe you're mid, you feel like you can build a full stack application, you want to like take your skill level to the next level. What are those advanced topics that like you should understand or know or try to like reach out and learn, right? So I'm going to walk you through a list. This is not an exclusive list. I'm probably missing a lot of stuff, but I want to kind of just talk about these keywords and kind of explain why they're important and why they're more like advanced. And also, if you are an advanced programmer, you've been doing this for a while, leave a comment. Let us all know, like, what are some things that you think, a senior level developer needs to know to kind of upgrade their skill set. So let me kind of walk you through like the different, junior, mid, senior roles that, people typically are. And I want to talk about like what are the responsibilities of those. So a junior developer's responsibility is to like basically learn the syntax of a language, learn how to implement some basic things, and learn how to basically learn, right? Their job is to get better at learning new things because that's all you're going to be doing throughout your whole career. And a junior is like someone who probably needs to be handheld a lot of the times. You can't give them a task and expect them to finish it on their own, right? Now moving up a level, so after they learn, the syntax and the basics of a framework, maybe they can kind of get some features done. A mid is like you can give them a feature and they can pretty much, get it all done themselves. They might reach out once or twice to get like better opinions on how to implement something, but for the most part, they don't really get stuck as much. And they're really, pretty decent at the web frameworks that you might be using like Angular or React. They have the syntax of the language, JavaScript, Go, whatever you're using, pretty down packed. And I think at a mid-level, at some point, like you start to touch on some of these things and you kind of understand like how you might need to do them. And then a senior dev is like, you already know the frameworks, you know the languages. Now you've moved on to advanced topics, which we're going to talk about here. And then also some other stuff that's more like interpersonal skill sets, like, how do you train people? How do you lead a team? How do you be able to take these complex topics and break them down into smaller chunks so that other people can understand them? How do you actually like hold the hands of juniors and walk them through what they're trying to do? So as far as advanced topics, most of these boil down to like code maintainability and code maintenance, right? So when you're advanced, your goal is not to just knock out features. Your goal is to write features that could potentially be maintainable for the next 5-10 years, right? If you can write software that is modular, that's easy to kind of plug and play and remove different third-party libraries and stuff, then you've kind of achieved an advanced level of understanding of building software. I think a lot of stuff on YouTube doesn't really teach much of this. It teaches more of like, this is how you just make something, right? And there's not really any extra thought into why are we doing the things we do? Why is a project structured in this way? Why do we use this over that, right? So the more advanced you get, the more you have like this internal debate or this weighing of one tech versus another tech. Why did I name something this instead of that? Why did I put this in a module instead of that type of module? Why am I splitting this up into smaller code bases? So if you want to kind of, get better at advanced web development or advanced programming, these are some of the acronyms I recommend you kind of go through. So the first one is WET, write everything twice. These two kind of boil down to abstraction and when do you actually start taking your code and, splitting it up into helper functions. Right? If you do this too much, if you try to write like little helper functions and little abstract modules for everything in your code base is just going to become really complex and unmanageable, right? So write everything twice is a good rule of thumb to make sure that the only time you abstract stuff away into helper modules is when you know for a fact that there's 2 places or maybe 3 places in your code base that do the exact same thing. Okay, so it's always good to keep that in mind. Like when you're writing code, it's like, is this something I need to abstract away? Am I finding myself like duplicating the same, 5-10 lines of code everywhere? Can I abstract this away? So the other one is dry, which kind of means don't repeat yourself. Again, this is a way to like know when do you abstract code away. And again, it's just if you see duplicate code in different places, obviously you should probably write a helper function. You should abstract that into a smaller module or a smaller class. understanding the responsibilities. I just kind of thought of some more. There's like coupling and cohesion is another one. Dependencies. There's just so much stuff that I could kind of go on. So let me try to go a little bit quicker. So KISS, keep it stupid simple, is another great one that you should kind of follow. I think I have a video on this one where I say it's kind of one of the most important ones. As you build larger projects and larger systems, stuff becomes really complex really quick. So I think it's kind of our job as advanced developers and advanced web developers to always be looking out for, like, have I reached that threshold where stuff is just too complex? And if I have, then I need to just take a stop, take a break, rethink about what I'm doing, and refactor whatever this complexity is and try to find ways to make it simpler. I feel like the better you get at coding, the better you become at just making stuff simple, easy to read, straightforward to follow the logic. So keep it stupid simple. That's something you should kind of always keep in the back of your head, to make sure that the code you're writing isn't just getting unmanageable or unmaintainable or out of hand. Because again, like, you have to come back later and read this code, and other people who have never seen this code have to come back and read it as well. So it's kind of important to do this. And there's some things that help with keep it stupid simple, is like using linters, like ESLint, using Prettier to code format everything, just to make sure that all your code looks exactly the same no matter who wrote it. Stuff like that. So coupling and cohesion, like, this is a term that you can kind of read up on. Coupling is basically when two modules depend on each other, they are coupled, right? So the more coupling you have, if you imagine that your code base is like a graph, so you have like all these different circles with lines, directed lines connecting to each other. If you have one module that has like 20 things that it imports, then the coupling of that module is very high, right? That module depends on a lot of different stuff. And if any of those 20 different imports get changed, you could potentially break your module. So coupling, you want to keep low coupling and high cohesion. I should probably put, these adjectives in front of this. Low coupling means that all your modules, you try to reduce the amount of things that they depend on, so that if you ever need to swap them out, or if you ever need to refactor something, there is a lower chance that you're going to break everything in your application, because instead of this one thing depending on 20 things, it only depends on 2 or 3, or vice versa. How many things depend on this module, right? If 100 different things all depend on this one module, when you go and you refactor that one module, you have a high chance of introducing like hundreds of bugs in your code base. So you want to kind of reduce the amount of coupling between these components so it makes it easier to refactor down the road. Cohesion is another term that you should learn. Basically, this kind of deals with, sometimes it deals with project structure. So things that are kind of closely related, like authentication, then you should keep all of the helper functions and all of the code that's related to authentication close together. So it's very easy for a developer to go and find out where that code is. Right? So this could be like making a single, authorization authentication module and have all your functions be inside of that. What you don't want is, like, you have one authentication module here, and then you have like another one, over here, and you have another one over here, and then another one over here. It's basically like finding a way to like make these things live closer together so it's easier to manage and easier to maintain. Dependencies, this kind of goes with coupling. So like you always want to try to make sure that whatever dependencies, let me spell that right. So when you're coding, if you're using Node at least, you end up bringing in like hundreds of these third-party libraries, and you're kind of dependent on them. And understanding how to like maintain these dependencies, how to update them, like you should be updating these dependencies as often as possible. If you're on a project where you haven't run an npm update in like 3 months, you're doing it wrong. You should be running npm update like every day, as often as possible. Get those patch updates in, get those minor updates in. When a major update comes in, try to update and refactor your code. And then also you want to kind of insulate your code base from dependencies. As we've seen, like there's libraries on npm that just get deleted, like the faker library. There's libraries out there that just have high security bugs like log4j. And you want your code base to be very easy to refactor if one of these dependencies goes rogue, right? So if log4j has a huge 0-day vulnerability, you want your code base to be super easy to just go into one file Instead of importing log4j, you might import a different logger library and you're done, right? But if you had 500 files and they're all importing log4j separately, you're kind of going to be spending like a week like refactoring all that code, because now you have to like change the imports, maybe change how your code is interacting with this third party module. It becomes a mess. So as you become more advanced, you start realizing that you have to like write facade patterns to wrap these dependencies to make sure that your code base isn't dependent on the third party library. Instead, your code base is dependent on a single module that's in your library that calls that third-party library. And then clean architecture. This is a way, I think it kind of hits on different things. It hits on dependencies. It hits on cohesion and coupling. I think I have a little module about this, which talks about dependency injection. Basically, clean architecture is a pattern you can use to separate your code base into different layers. Right, when you're writing code, you typically have like, your front end, you have your back end, you have your database, you have like these different layers, and clean architecture helps keep these layers very insulated from each other so that responsibilities don't like bleed into other layers, right? For example, in your business logic should have absolutely no idea what type of database you're using. All your business logic needs to do is call a function called like store to do item, right? So if for whatever reason you need to refactor off of Mongo and you have a bunch of Mongo statements sprinkled all throughout your business logic, it's going to be very hard to refactor. This again goes back to the dependencies talk. Clean architecture is like pattern you can follow to help reduce this risk by basically, anything. I don't want to get too into the weeds of this, but just read up on it. It's really important. You basically just need to make sure that all your layers have a single set of responsibilities and they don't know about other stuff. So like business layer doesn't know about database. It also doesn't know about Express. So if you're making like an Express API, you don't want your business logic to know about rec and res. All your business logic should do, all your business functions should do is just take in some arguments, such as like a to-do list string or to-do list text, and then it should persist that somewhere by calling a function. It shouldn't know about express.rec.body.query, whatever. It should just take in some data, store that data, and that's it. But that's a whole nother advanced topic. And typically to achieve clean architecture, you do something called like dependency injection or dependency inversion, or you can do like IOC containers. Basically, it's a way to have it so your business logic or your functions don't require these things directly. Instead, they're passed into via like constructor injection or method injection or function injection, where basically, you don't want your business logic being directly coupled to your persistence methods. You want those persistence methods to be passed in so that you can easily swap them out in the future if you ever need to. I'm going to stop talking about these two topics though, because they're just a whole nother can of worms. So as you get more advanced, again, there's something called solid, which I need to go back and refresh my memory on what some of these O's mean. Let's see. C, I think D is like dependency. I is, there's like some whatever Lewinsky's principle or something. S, let's just look this up. I don't even remember. All right, solid principles, single responsibilities principle. So like, again, this is just an acronym for helping you write more maintainable, manageable code, where basically S stands for your modules should only be responsible for one thing, right? So if you write your functions really small and they only do one little thing, that's great. You ever notice that you have a function that has like a bunch of if statements and it has like a bunch of toggles and it does a ton of different code? Maybe it's doing too much, right? Maybe you need to refactor that function into smaller functions so it can kind of satisfy the S in solid. O, open close principle, is like, I think it's like open for extension, closed for modification. But basically it's like whenever you write a module, you want it to be very easy to extend, whether it's like you're passing in arguments that allow it to do more functionality. And you shouldn't have to go into that module and like modify code just to support something new that you're trying to do. This thing is easier said than actually done. I mean, it's very hard to write code that's abstract enough that you can just like extend like this. And sometimes I think it gets you down into a boat of over-engineering, so be careful about this principle, but it's good to know about. Liskov's substitution principle. I don't even remember what this one is, to be honest. It's super confusing. Like, let's see. I think it has to boil down to like abstraction, like, you know, not interfaces, but like having classes and having those classes be extending from other classes where you can basically like your parent class shouldn't have to change your child class or something. Let's see. In other words, as simple as that, a subclass should override the parent class's methods in a way that it does not break functionality of the client's point of view. So this is more like for object-oriented programming. I don't like object-oriented programming, so this I don't really know how to explain that one. But there's two more. Interface segregation principle. I think this one basically boils down to, you have two modules that talk to each other. You should have a interface in between, which acts as a contract between like how these two things communicate, right? You don't want this thing, you know, fully depending on this module. You want an interface in between so that it's easier to swap out down the road. And I think dependency inversion principle, again, is kind of, maybe I just explained that one. Like entities must not depend on abstractions, or entities must depend on abstractions, not on concretions. So there's like this idea like code can be abstract or it can be concrete. So a piece of functionality that talks to a database is concrete code. Your business logic is more abstract, right? So your business logic should not import or require directly on your persistence MongoDB function. It should be passed in with a dependency inversion. Let's go back up to this one because I think I kind of slaughtered with this one. Interface segregation principle. A client should never be forced to implement an interface that doesn't use, or clients shouldn't be forced to depend on methods that they do not use. I don't know. I need to refresh my memory on Solid. I feel like a lot of these things are more like object-oriented principles. But if you are using Java or some type of OOP language, then yeah, you probably want to go learn Solid, but let's not waste too much time on this. Abstraction. So again, this goes back to like dry and wet and, you know, also solid. Abstraction is like one of these key things in software that you can get wrong. And when you do get it wrong, your code becomes super unmanageable and complex. Abstraction is like taking some logic and converting it to like a more generic function so that no one really knows how it works. Like you just call it. It's like a black box. You call this function and it does some things. Declarative programming is really good. I don't know if I just switched topics completely, but declarative programming usually allows you to write code where you have like your main module, but it calls a bunch of abstracted functions. So understanding like when you want to use declarative code bases, which I think you should always use declarative code bases because they're much easier to understand and read and manage, versus procedural, or was it declarative and imperative? So just knowing like declarative, imperative versus all these other different like object-oriented programming versus functional. Those are topics that are good to understand. Object-oriented programming is cool. You have like these classes that kind of describe your data and your functions, and they couple those together. And there's a bunch of other terms that come with object-oriented programming. But functional programming is usually a lot easier to understand, and I think it's easier to manage because everything's just a single function. I've seen it when you do OOP and you have classes that become super large and you have all these functions that are doing like all these random side effects to the state of the object. I just don't like OOP, to be honest with you all. But understand like when you know, what's the difference between them? Clean Code. This is a book that's written by Bob Martin, I believe. But basically it has a lot of tips and tricks of like, how do you write your code to keep it clean and maintainable? Like what's the proper way to name stuff? How big should your functions be? I don't even know. I have to go back and refresh my memory about this book. It's a lot of the stuff that's written by Bob Martin is really abstract and hard to understand, and it's hard to apply to JavaScript because a lot of this is built for like OOP languages. Maybe you can apply it better to TypeScript, but it's good to understand like how do you write maintainable code. And again, using something like a linter or some type of like Husky pre-commit checks will help you keep your code clean. Reducing complexity. I think I talked about this before, but that's like the goal of being a more senior engineer and advanced developer is always try to reduce your complexity. Keep it stupid simple. Don't let stuff get out of hand. Make it so it's easy to understand for anyone new who joins the team. Maintainability, again, this is an important one. When you write code, like you need to write in such a way that if you were to die or get hit by a bus, there's an actual like saying hit by a bus factor that someone else can go and look at your code and understand exactly how it works. This doesn't mean adding comments everywhere. This means like naming your variables properly. Like don't use the variable I or J or X. Actually name what these things are, like index of users. Or I don't know, instead of X, you could say like X coordinate or something. Some things you can keep short, like X and Y, I guess makes more sense if you're doing some type of canvas graphical thing. But you understand what I'm saying? Like just spend an extra 5-10 seconds thinking about what you're going to name something in case someone comes along and tries to read your code and isn't completely lost. And then also like maintainability goes back to like when to abstract. Basically all this is maintainability. That's like the key that we're shooting for is maintainability. Like as you become more advanced, you're trying to write software that's going to last for 5-10 years so that people don't have to go and hire another team of developers to rewrite what you just wrote. You want your code to last. You want your code to be able to come in and be modified and changed. And the more maintainable you understand how to write your code, the more advanced of a programmer and the more valuable as a programmer I believe you'll become. Testing. Again, testing is this huge thing that I don't see many YouTubers really talk about, but testing is one of the most important things you can do in programming. How do you create a system that's maintainable for 5 or 10 years? Well, you write a bunch of tests. You need unit tests, integration tests, unit, integration, end-to-end, smoke. What else is there? There's load testing. There's probably some other testings as well, but you want to make sure that your system doesn't start falling apart or getting tons of bugs as developers, commit their code. If you're on a larger project, like 10, 20, 30 developers, usually most teams are around 8 to 10, but that's a lot of developers pushing code every day, right? So there's a high chance that someone changes one little function or module and breaks the code base for everybody. So you want to have a lot of testing set up. Code coverage, understanding like 95% is probably good enough. 100% code coverage is just out of hand. Knowing what to test. Like there's some things that you just don't care about testing. If it's a simple like getter function on a Java object, you don't test it. If it's a setter, you don't test it. You test stuff that has logic, cyclomatic complexity, and like understanding all these different things that you have to like watch out for. Linters, which check for complexity, is a good thing to have. There's like something called Sonar Cloud that can kind of check your code for vulnerabilities and check things that you might not be doing that are great. ESLint, prettier. You want your code to kind of look uniform. So as you have 10 different developers working on a code base, like it doesn't look like Bob wrote this code and then like Jane wrote this other code. It looks like the code is written by one person. So you want to have it set up in such a way that all the code looks really standard. Like auto formatters are good, etc. You can kind of keep on diving down that list. Documentation. So you want, even as a beginner, like I think this is something that people suck at. Even I suck at this. As you are building your software, you want to document your software. And that usually means at least keeping a README file set up and maybe like a contributing file set up that is up to date so that if anyone were to try to clone your Git repo, they can actually run your project and not have to stumble. Okay, so keeping documentation written and up to date is super important. And as you become more advanced, like it needs to be second nature. Like, oh, you're doing this. Well, maybe we should write a diagram to, describe how we're doing it in case I need to talk about this to the team. Getting good at writing diagrams, sequence diagrams, flow diagrams, and, understanding how to talk about those things and give presentations to other developers. Because sometimes we talk about really abstract things, like especially if you're dealing with Amazon Web Services and you have like this Lambda function that's kind of sending off an asynchronous message to SQS, another Lambda function, and then that Lambda function needs to talk to a database, and maybe it needs to send off an email at some point, and then you need to basically fan in all those computations back into a single Lambda to kind of process all that data and output something new. Like you can imagine, like that stuff gets complex, and you need graphs to kind of understand how all the data is flowing through your system. So understanding like how to document, how to like graph, even just using something simple, like I think Visio is one, or not Visio. I like using Draw.io. There's a lot of other software out there you can use to just take it to the next level. Like just draw diagrams, write down steps. People should be able to clone your repo and be able to reproduce exactly how you run it locally. They shouldn't have to go and like hunt down other developers and figure out why it doesn't work on their machine. Maybe looking up Docker or containerization. will help with that because now everyone has the exact same machine running locally and they don't have to like rely as much on documentation to get set up. But that's another topic. Like I don't want to get too much into the weeds of DevOps or security, but as you become more advanced in web development, you kind of have to branch off. You kind of have to branch off into, how do I deploy this stuff? How do I manage this stuff? How do I like monitor this stuff? Caching is one. So at some point, like you need to worry about the performance of your system in case caching is probably under performance. What are the tips and tricks of like making your web application more performant? And I think that kind of boils down to like server-side rendering, client-side rendering, server-side generation, and caching. Like you need to know what are the benefits of these. Some of them have benefits for search engine optimization. Some of them don't. Some of these things allow you to have a faster first contentful paint. So there's something called like Lighthouse that you can run to understand like how to track performance and metrics. You can run this to understand like how quick does your UI run, but also when you're dealing with like writing backend code, like you have to keep track of like, is what you're writing performant? Are you doing too many calls to a database? Maybe you're using like an ORM like SQLize and you're trying to do something simple, but behind the scenes, it blows up into like 1,000 different queries just to get some simple data. So the better you get at performance, the more advanced you'll become. Just make sure you're always trying to make stuff as quick as possible, as fast as possible, to just allow your users to have a better experience, right? And then also just to reduce the usage on your backend machines. And again, like this all boils down to like DevOps, understanding how to deploy, manage a large scale application. It's important to understand, and that's kind of like a different field in a sense, but I think more full stack developers are kind of learning how to do this type of stuff, and they should know how to do this stuff. They should know how to like write infrastructure as code. So something like Terraform, understanding how to write code that actually will deploy your entire application to Amazon or Microsoft Azure. So that's like another topic. I don't want to get too much into this, but it's just the list just keeps growing. Like at some point you need to understand security, like, I don't know, header security, what do they call it? Content header security, stuff like that, CSP security. If you ever need to do authentication, like you need to know about cores, you need to know about like these different vulnerabilities that you might have, like XSS attacks. So it's always good to know about security because you don't want to write code that is insecure. So as you get more advanced, like you need to understand some of this stuff and how to set it up. I know there's security is like a completely different field and you can actually hire like security experts, but at the very least, you should know some of the basic security concerns of hosting your own UI or hosting a backend, just so that you can have a pretty resilient application. If you think that this isn't your job or this isn't your concern, and you have like a security expert on your team, I mean, I think you should still learn it and then kind of consult with that security expert, and he can kind of show you or tell you like, no, you need to do this because you're missing this, this, and this. But security is like a spectrum, right? You could spend like years making everything perfectly secure and it still might not be secure. But yeah, just keep that in mind. And then scale, this again goes with like DevOps and infrastructure as code. But I think branch off and learn more about DevOps and security and performance is like the next levels. And now you're like bleeding into other responsibilities, but knowing how to like scale up your API using like a CDN or cloud-based infrastructure using like edge computing, it's important to understand. And then also your backend, like understanding how that, can be scaled up, what type of databases there are. You could do like Mongo or NoSQL versus SQL. How do those perform at scale? Why is NoSQL typically easier to scale up? Understanding about clustering. What else is there? There's like blue-green deployments, auto scaling. Like there's so many different keywords that I could probably type in the DevOps, but just understanding more, like branch out from like just learning about React and Angular, branch out and learn like, okay, how do I actually like deploy this stuff and how do I make it so I can deploy a new feature, not break it for people who are out there? Like migrations are important, understanding how to, I don't know, have zero downtime deploys. is important. I know a lot of people just use like pre-made services like Amazon Amplify or Vercel, but at some point, like if you're working at a larger corporation, they're going to want you to save money. And sometimes the only way to save money is by doing this whole like deployment process yourself. In fact, I'm surprised I didn't talk about CI/CD. This is like super important. So understanding how to like set up a pipeline where basically when developers push code, it takes that code, it lends that code, tests that code, deploys that code, tests it again when it's deployed to a real environment, and then finally gets that code into production. Like understanding how to set that all up with, I don't know, let's say you're using GitHub Actions, or let's say you're using something like Circle CI. Like just getting some experience setting this all up yourself so that you as a developer, when you make a PR, you know if your code's breaking something, right? Security, I could put linters. Anyway, I'm gonna stop putting stuff down because at this point, like I've talked about a bunch of stuff. There's just too much stuff to learn. But I hope that kind of gave you a good overview of like how do you take your game to the next level? What are these things? Like why do you need to learn them? How do they help you become more advanced? And hopefully I kind of gave you a good overview. And just, you know, pick and choose some once in a while and just try to learn more about it and make sure you understand like what this stuff is. If you have a topic that I missed that you think is like super important as a advanced developer, leave a comment. I'm definitely curious in hearing your opinions. But anyway, hope this helped. Have a good day and happy coding.